Hello everyone, I am Karthik from ITA section and my roll number is 20951230. In disaster management, our topic is about climate effects on us, infrastructure, the economics of adaptation for railroads and the coastal development. So let us see about the tech talk topic was given to us in briefly in further slides, and how the climate will affect on infrastructures, likewise on roads, rails and coastal, how the different sectors are being affected through the climate changes and the disasters that will frequently happen in a year. So let us see briefly about this and know about this topic in further slides. Briefly, let us dive into our topic. Coming to the abstract, changes in temperature, precipitation, sea level and coastal storms will likely increase the vulnerability of infrastructure across the USA. Using models that analyze vulnerability impacts and adaptation, this paper estimates impacts to railroad, roads, and coastal properties under three infrastructure management responses scenario: no adaptation, reactive adaptation, and proactive adaptation. Comparing damages under each of these potential responses provides strong support for facilitating effective adaptation in these three sectors. Under a high greenhouse gas emission scenario and without adaptation, overall costs are projected to range in the $100 of billions annually by the end of this century. Thus, first tier of adaptation action, however, reduces cost by a factor of 10, and the second proactive tier reduces total costs all three sectors to the low $10 of billions annually. For the rail and road sectors, estimated cost of reactive proactive adaptation scenarios capture a broader share of potential impacts, including selected indirect costs to rail and road users, and so are consistently about a factor of 2 higher than prior estimates. The results highlight the importance of considering climate risk in infrastructure planning and management. If we look at the introduction, climate change is affecting infrastructure system across the USA in far-reaching ways, and the impacts are projected to worsen over time in many regions. Extreme temperatures and precipitation events are damaging roadways and threatening the integrity of the rail system as a sea level rise and storm surge erode our coastline and damage property and infrastructure, particularly during heavy storms which are occurring with the greater frequency and intensity. uh, mm, the major infrastructure system are critical to the nation economy, security and culture as they facilitate the commerce, transportation and social well-being. Already the US road and rail systems are in poor condition, with a large portion exhibiting significant deteriorations and in need of repair replacement. Coastal infrastructure is also exceptionally vulnerable, with existing problems such as shoreline erosion, coastal flooding, and water pollution expected to worsen with the climate change. To address these challenges, engineers and infrastructure planners suggest a need to adapt the way we operate, maintain and upgrade the expand the nation's infrastructure aspects, methods and the data. So summary of the costs of included in the three adaptation scenarios. Rail costs include cost of no adaptation in no adaptation case, cost of replacing track to repair lateral alignment defects in the bulking zone, and cost of realigning rail in adjoining zones, and cost of delays that occur due to track buckling and repair. Cost of replacing track repair lateral alignment defects in buckling zone, and cost of realigning zone in adjacent zone are happened in a reactive adaptation. And cost of purchasing, installing and maintaining the track temperature sensors and related software infrastructures are happened in a proactive adaptation. Costs do not include cost of derailment that may reduces from track bulking. Cost of routine track maintenance include winter maintenance are occurred in no adaptation. Cost of derailment that may result in track bulking, and cost of developing and implementing the speed orders, and cost of routine track maintenance are occurred in reactive adaptation. Cost of routine track maintenance are occurred in proactive adaptation. Road cost includes a repair cost limited to the historical spending, with the priority given to the repairing damage from extreme precipitation, and precipitation cost of delay due to the repairs are occurred in no adaptation. Repair cost and cost of delays due to the repairs are occurred in reactive adaptation. Upfront capital cost of proactive strengthening, repair cost of delays due to proactive strengthening are occurred in proactive adaptation. So costs do not include in roads or routine maintenance costs are occurred in no adaptation. Routine maintenance costs are occurred in proactive adaptation. Uh, Routine are called in proactive. And coastal also have the different value properties that will be adopted according to the various adaptation methods. Climate projections were selected to be consistent with those used in the fourth NCA. The analysis used representative concentration pathway uh, with 8.5 as a higher greenhouse gas emission scenario, and RCP as a lower scenario. RCPs are identified by their total approximate radiative forcing in the year 2100 relative to 1750. The analysis employed 5 global climate models selected based on the criteria detailed in the USCPA and the associated technical appendix. The 5 models applied here were from the Canadian Centre of Climate Modeling Analysis and the National Centre of Atmosphere Research, NASA Goddard and Ocean Research Institute, National for Environmental Studies, and Japan agencies for the technology. Rail Chalkers estimated the impacts of the projected changes in temperature on the currently existing Class I rail network in the USA. Specifically, this work analyzed a reactive adaptation scenario in which operators implement blanket speed restrictions during periods of high temperature to avoid track bulking events, and proactive adaptation scenario in which operators use the track temperature scenarios to optimize their speed restrictions. The analysis estimated the cost of delays in each scenario along with the capital costs of installing sensors in proactive adaptation scenario. In this method, train delay minutes are first calculated based on the speed restrictions, the length of the track in the grid, and the number of hours in which the speed order will be put into effect. Once the total delay minutes are calculated on per grid basis, the daily minutes per year calculated by multiplying the delay minutes per the grid and the number of incidents per grid. This is the formula that we calculated for maintenance. Roads our previous analysis of the current US roads network focused on evaluating the potential impacts of the climate change in reactive adaptation scenario, in which roads are repaired in a response to climate change related, and in proactive adaptation scenario, which roads are protected and rehabilitated in prevent future impacts on the climate stresses. So these are the no adaptation, reactive and proactive adaptation change in cost according to various scenarios. So the figure shows the change in cost to the USA rail network in 2019 related to baseline under the RCPA 2. So the figure 2 shows the change in the cost to the US roads sector in 2019 reactive baseline. Coming to the conclusion, the results also clear that the benefits of the action for both adaptation and greenhouse gas emission mitigations are large, even if there appears to be little potential completely eliminate residual damage and cost with the most expensive adaptation plans. Thank you.